Hello students, welcome to class 12 physics. In this video we are going to derive the equation of current for AC voltage that is applied to an inductor. So obtain an equation of current for AC voltage applied to an inductor and draw a graph of V and I. So as you can see over here, we need to find the equation of the current for voltage that is applied to an inductor. So in this circuit we are having the AC source as well as the inductor. So in figure that shows an AC source connected to an inductor. Inductor has negligible resistance. Thus the circuit is a purely inductive AC circuit. Let the voltage across the source be V equals to Vm sin omega t. That we have already discussed, that the AC source, that is the voltage, AC voltage applied V, that is equals to Vm sin omega t. Using the Kirchhoff's loop rule, V minus L di by dt equals to 0, because here we are choosing the path like this and the current path is also in the same direction. So here we need to apply the Kirchhoff's voltage law. So starting from this AC voltage, we can write V, that is AC voltage, here the current direction and the path, both are same, path that we are choosing both are same, so sign will be minus, and the voltage developed across the inductor, that is taken as VL, and here now there is no other component, so it is equals to 0. Now the voltage developed across this inductor, that is nothing but VL is equals to L di by dt. So this equation can be rewritten as V minus L di upon dt equals to 0. So we got this equation. Where minus L di by dt is the self-induced EMF. So taking that on the other side, we can write it as V equals to L di by dt, and di by dt equals to V by L. Taking just the cross multiplication, taking di by dt as the subject. Now substituting the formula of V, that is V equals to Vm sin omega t, the equation becomes d by dt, that is di by dt equals to Vm sin omega t upon L. Now taking this dt on this side, so we get the equation as di equals to Vm upon L sin omega dt. Here L is the self-inductance, and equation 1 indicates that current IT as a function of time must be such that its slope di by dt is sinusoidally varying quantity with the same phase as the source voltage and an amplitude given by Vm by L. So to obtain the equation of the current, you can see this equation, we have di on the left hand side. Now to get the current in the circuit, we need to integrate both these sides. So integration of di equals to integration of Vm by L sin omega t dt. So taking Vm by L outside and taking integration of sin omega t dt. On the left hand side, integration of di becomes I equals to, in this equation, Vm by L and integration of sin omega t, that is minus cos omega t, and from this omega t, taking its integration, it will be divided by omega. So the total equation becomes minus Vm upon L into cos omega t upon omega. Here we are taking the limit from 0 to t, that is, now the equation becomes I minus Vm upon omega L cos omega t. Here writing the equation cos in terms of sine. So we know that cos theta equals to sine 90 degree minus theta, or it can be written as minus sine theta minus 90 degree. So cos theta is equals to minus sine theta minus 90 degree. Taking minus both sides, this right hand side becomes positive, that is minus cos theta equals to plus sine theta minus 90 degree. So replacing this minus cos omega t by sine omega t minus 90 degree, that is pi by 2. So equation becomes I equals to Vm upon omega L sine omega t minus pi by 2. And here omega L, that can be considered as the inductive reactance, and we know that the voltage upon the resistance is equals to current. Here Vm upon R becomes Im. Instead of the resistance over here, we are having inductive reactance, that is XL. Here omega L is taken as XL, that is inductive reactance. So that is also nothing but the resistance offered by the inductor. So that we can replace by XL, and Vm upon XL can be written as Im. So now the equation becomes I equals to Im sine omega t minus pi by 2. Here omega L is called inductive reactance, that is denoted by XL, and its unit is ohm. The inductive reactance limits the current in a purely inductive circuit in the same way as the resistance limits the current in a purely resistive circuit. The inductive reactance is directly proportional to the inductance and frequency of the current, that you can see from the equation XL is equals to omega L. So it is directly proportional to the inductance as well as the frequency. Hence for the source voltage and the current in an inductor, V equals to Vm sin omega t and I equals to Im sin omega t minus pi by 2. So this shows what? That the current lags the voltage by pi by 2. In the case figure A shows the voltage and current phasors in the present case at instant t. As you can see in figure A is nothing but the phasor diagram. So here the voltage makes an angle omega t1, it makes an angle omega t1 with respect to this axis. So and we know that current lags the voltage by 90 degree, that is omega t minus 90. So from this omega t angle 90 degree is to be subtracted, and these vector that we are getting, that is nothing but the current. So taking the projection of the voltage on y-axis will give us the Vm sin omega t1, that is this, and taking the projection of the current on y-axis, here we are getting the current, that is Im sin omega t1 minus pi by 2. So this is the phasor diagram, and as you can see over here in this graph also, we are having voltage V equals to Vm sin omega t, that is at 0, pi and 2 pi its value is 0, at 90 degree and 270 degree we are getting the maximum voltage, and for current it is lagging by 90 degree. So at pi by 2 and 3 pi by 2 its value will be 0, and at 0, pi and 2 pi we are getting the maximum value. The current phasor I is pi by 2 behind the voltage phasor. pi by 2 equals to t by 4, that is pi by 2 equals to t upon 2 pi into 2 pi by 4, which can be written as pi by 2 upon omega equals to pi upon 2 omega. When rotated with frequency omega counterclockwise, they generate the voltage and current given by V equals to Vm sin omega t and I equals to Im sin omega t minus pi by 2 respectively. And as shown by figure B, this graph is for V and I versus omega t. So students, you may note down this theory.